Okay, let me do a couple of videos on 11.8. Okay, now we're starting to get into what series were really meant for. We're going to do power series. And what's a power series? Power series is a polynomial. And here's how you write it. Summation n equals, usually start at 0. You can start wherever, but usually on these will start with 0. I'm kind of show you why. A-n x to the n. Okay, so I got a sequence piece. This whole thing's a sequence, but you'll have this part right here. That's going to be a constant times a variable to a power. Now, if we look at that, that's going to be a0 times x to the 0 power, but x to the 0 power, that's just going to be 1. So that'll be a0 plus a1 times x to the 1 power plus a2 times x squared plus dot, 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 and goes on forever. And you see that's a polynomial. It's not a normal, it's an infinite polynomial. And so here's your constant, here's your first degree term, your second degree term, and so on out. Now, you can also have power series written this way, n equals 0 to infinity, and you have your constants, but you can shift this guy, move it off. This guy's centered at 0. You can have a power series that looks like this. So what would that be? Each term would be, so you have a0 x minus c to the 0 power, which would be, this would be 1, so you just have a0. Then you're going to have plus a1 x minus c to the first power plus a2 x minus c to the second power plus on out forever. The only difference between these two is this guy's centered at 0 and this guy's centered at c. So basically you just shifted it, c units subtracted, you go this way or that way. When you subtract, you're moving it that way. So this guy's just been shifted c units that way. If c is a positive number. If c is a negative number, you move it back the other way. Okay, so let's look at some examples here. So let's pick a real simple one to start with. Get your feet wet. I'm going to look at summation n equals 0 to infinity of 1 times x to the n. So each one of the coefficients is 1 in this case. So that's going to be 1 plus 1 times x to the first power plus 1 times x squared plus whatever, and then you get x cubed plus dot, dot, dot forever. Okay. Now, this power series will converge some places and won't converge some places. So what does this guy really look like? Well, there's no real reason to write the 1 there, so that one's important. These aren't. So there's your power series. But what is this? This is a geometric series. And what's your first term? The first term is a 1. And what's going on here? So this guy's going to converge. So this guy's going to converge if what? If your ratio, this piece right here, is less than 1 in absolute value. So this is going to converge if x in absolute values is less than 1. How do you solve that? Well, that's going to say that x is between the 1s. That's a distance from 0 has got to be less than 1. So x is going to be between the 1s. Okay, so there's all the x's that'll work. If x is equal to 1, this guy blows up. If x is bigger than 1, this guy blows up. But if x is less than 1, this guy will converge. And we know exactly what it converges to. And so we can say, just put this on a number line. What all x's work? Well, here's 0. And it goes all the way out to 1. To 1 it works. All the way down to -1 it works. But it doesn't include the endpoints. So if you're doing this as an interval, so its interval of convergence is a -1 to 1. Now in your book, they'll talk about radius of convergence. So here's the interval of convergence, what I think is the most important part. These are all the x's that will work, they'll make this series converge. Anything outside of this guy will blow up. So this is your interval of convergence, and then I'll talk about how to have a radius of convergence. We'll take the middle point. What's the middle point? The middle point in this guy is 0. And so I go from 0 out to one side or 0 to the other side. That radius to get out to the end point was 1. So the interval of convergence, -1 to 1. Its radius of convergence is 1. So from the center out to the side. Let's look at another one real quick. So I'm gonna take that same series and I'm gonna shift it over 3 units that way. So n equals 0 to infinity of x minus 3 to the n, okay? And so what's this gonna be? That's gonna be, when you plug in a 0, that's gonna be 1. You plug in a 1, you're gonna get x minus 3 to the first power, then x minus 3 squared plus goes on forever. Now this will work as long as this stuff right here, here's your ratio, as long as your ratio in absolute values is less than 1. Okay, so that means this quantity here has got to be between the 1. So I got x minus 3 has got to be less than 1 or bigger than a negative 1. Now to solve an inequality, it's been a while since you've done inequalities. You can add whatever you want to an inequalities. These don't change. You can add plus or minus numbers and this doesn't change. But if you multiply through something, if you multiply through it by a positive number, inequalities stay the same. But if you multiply by a negative number, they flip over. Multiply or divide by a negative number, these guys will flip over. All I want to do is get rid of that 3. So let's add 3 to all the places here. And the minus 2 and a 3, it's going to give me a 2. Is less than, that's going to be x plus 0, so that's x. Less than 1 plus 3, that's 4. Okay, so this guy works on a number line. Where's this guy centered at? This guy's centered at 3. So it's centered at 3. And I'm going to go out to 4 and back to 2. And everything in here works, not including the endpoints. So its interval of convergence would be 2 to 4. Its radius, that's its interval of convergence, and its radius of convergence. How far is it from the center? The center is 3, out to 4 is 1, and back to 2 is 1. So its radius of convergence is 1, just like the other one. And that's exactly the same as the other one. So what I do, I shift the center from 0 for the last problem and shifted it up to 3. Okay, so let me do one that's a little more complicated. But the thing here is the radius of convergence and the interval of convergence is the important thing. They make a big deal about radius of convergence, and I don't think it's that important. If I got the interval, these are all the pieces that work. That's what I'm really looking for. Okay, let's look at, I got summation n equals, I think this guy starts at 0. No, it can't start at 0. This guy's got to start at 1. 1 to infinity, and I got 2 x minus 5 to the n and n over n. Okay, so I want to see if that guy converges. Okay, I'm not quite sure what to do here. It's not a simple geometric series like the other ones were. Let's see what we can do. Maybe I'll use the ratio test. So I'm going to try the ratio test and see what happens. Okay, so the ratio test, what's ratio test do? You take the limit as n goes to infinity of a n plus 1 over a n in absolute value. And if this thing goes to a number that's less than 1, this is absolutely convergent. If it goes to 1, the test doesn't work. And if it goes to a number that's bigger than 1 or goes to infinity, then this guy diverges. So I got to check this limit out. Okay, let's look at that. So we got the limit, n goes to infinity of a n plus 1, because I got to put an n plus 1 on these two spots. So it's going to be 2 x minus 5 to the n plus 1 over n plus 1. And then I got to divide it by this guy. If I'm going to divide it, so that means I'm going to flip it. And so then I'm going to get n over 2 x minus 5 to the n. Now, as an absolute values, and you'll get sloppy and you'll drop the absolute value bars and it'll screw you up. Because I don't know this thing's positive, because I don't know what x is. So I need my absolute values because I'm not sure what x is. Now, let's look at this. Let me clean this thing up. So we got limit, n goes to infinity. And now I'm just going to rewrite all this stuff. And rewrite the top. I got a 2. I got an x minus 5 to the n plus 1. So that gives me an x minus 5. And then an x minus 5 to the n. And then I got an n. And on the bottom, I got a 2. I got an x minus 5 to the n. And I got an n plus 1, and that's times there, and then it's an absolute value. So now what'll happen, these guys die, and so you're going to get the limit n goes to infinity of what we got now. We got x minus 5, and then we got n over n plus 1. You get instant absolute values. Now, as n goes to infinity, what's going to happen in this piece? Since I have a lot of board, I'm not going to go through all the details. As n goes to infinity, n over n plus 1 goes to 1. So that's going to go to 1, so this thing's going to end up equaling absolute value of x minus 5. Okay? What did we use for this test? We used the ratio test. So if I want to find out where this guy works, I got to make this guy right here less than 1. So since I used the ratio test, I need absolute value of x minus 5, because this was the limit. I need that to be less than 1. That's what we're working on. Okay, how do I make that happen? Well, that means that x minus 5 is in between the 1. So I got x minus 5 is less than 1 and bigger than a negative 1. I got to add a 5 all the way across. Since I'm adding, I don't have to worry about the inequalities. So that's going to be a 4 less than x, so that's 0, is less than 6. So what's my interval of a convergence? Or on the number line, let's look at it first. Its center is going to be at 5. And I'm going to go out to 6 and back to 4. So it's going to be everything in here, and it's less than. So I'm going to put circles in here, and it's everything in there is going to work. Okay, happy with that? You shouldn't be. We screwed up. Okay. The ratio test works if x is less than 1. So I know that all the numbers in here work. And if it's bigger than 1, so all the numbers out here won't work. So I know it's going to diverge out here. And it's going to converge in here. But the ratio test doesn't work where it's equal to 1. So what happens if I put in a 4 here? 4 minus 5 is a negative 1. Absolute value of negative 1 is equal to 1. Ratio test doesn't work. What happens if you put in a 6? 6 minus 5 is 1. 1's equal to 1. Okay? So the ratio test doesn't work at 4, and it doesn't work at 6. Well, don't complain too much. The ratio test gave you an infinite number of numbers. I know that anything from 4 to 6 works. I just don't know about 4 and 6. So what you have to do is go back and on your endpoints, plug that back into the original function, the original series, and see if things work. So I know for a doubt, without a doubt, that from 4 to 6 works. I just don't know if I need to put a bracket or a parentheses. So do I put a bracket or a parentheses? I don't know. So I got to check out 4 and I got to check out 6. So let's see what happens at 4 and 6. So I just don't know what to put here. Do I include that endpoint or not? Okay, so let's check out 4, because 4, I don't know, because 4, when I did the ratio test, ended up giving me 1. So put in a floor, not a floor, you put in a 4. So put in a 4, I'm going to get 2, and I got what? 4 minus 5, that's a minus 1 to the n over n. You can pull, since it's an addition, you can pull that 2 out. Okay, what's this look like? That's an alternating series. It goes plus minus plus minus. And it's 1 over n, so it's decreasing, alternating, so I know this guy converges. So what do I need with the 4? There's no question anymore. Everything this side of 4 worked up to 6, but did 4 work? 4 did work, so I got to put a bracket there. Now let's check the 6 out. So this was checking out the 4. Let's check out the 6 now. See what happens. So I'm going to do, when I do that, I can pull out the 2. Got summation, 6 minus 5, and that's going to be 1 to the n over n. 1 to the n is just 1. What's this thing do? Summation of this guy diverges. That's a divergent p-series. So what do I need to put over here? 6 does not work. So my interval of convergence is 4, including 4, up to 6, not including 6. And what's my radius of convergence? The center's 5, goes out to 6, that's 1, back to 4, that's 1. So its radius of convergence is 1, It's interval convergence. It's 4 to 6. Include the 4, don't include the 6. And I think I'll stop there. All right, have a good day.